Yo, what's up guys, welcome to another amazing video of my channel Smarter Everyday. And in this video I'm going to be continuing with the chapter Force and Motion, that is going to be the part 3 of physics, that is a sub-branch of science. And I know the video couldn't come for 1 month because we had our reviews going on, but from now on you will get regular video uploads. So as I told you, we're going to be continuing with the same chapter Force and Motion, that is going to be part 3. So yeah, why to wait, let's begin. But before starting, don't forget to like, share and subscribe to my channel. So now let's begin. So the points going to be covered in this video are velocity, acceleration, then we're going to do the summary of all the things like velocity, acceleration, and in the previous video also we saw the average speed, etc., distance, displacement also. So we're going to summarize all of them now, and not only these 2 points. Then we're going to be seeing uniform motion and what is non-uniform motion. So now let's move to the first topic, that is velocity. So what is velocity? So the velocity of a body is the distance traveled by the body in a specified direction in unit time interval. So unit time interval is very important when you're writing the definition of velocity. Velocity is a vector quantity that it has both magnitude and direction. Now we even saw speed. So now there is no much difference between speed and velocity, but there is. So now speed is only good for in everyday phenomena, like everyday. Like the car is going very fast, the car is going very slow. That is everyday. And the speed is good for that. But it does not explain about direction. If you want to tell about direction, speed doesn't. So you have to use velocity, and even that speed measures distance in a given time. But velocity measures displacement and not distance in a given time. And hence velocity is a more scientific way of expressing speed. And for velocity we use the SI unit, that is meters per second, that is like meters per second. And for bigger units, like for Bangalore to Pune, Pune to Bangalore, Bengaluru, then etc. So that can be expressed in kilometers per hour. And now to calculate velocity, we have a formula. That is, velocity is equal to displacement upon time taken. So this is the formula for finding velocity. Now let's move to acceleration. So now we see that in our day-to-day life, our everyday phenomena, we see that cars and buses don't go at a same speed. Like we have bumps, we have people, we have speed breaker, etc. that come in the road. So the cars, buses, etc. have to slow down. So that means that they do not move with a constant speed. We'll take an example. We'll take that there is a cyclist. This is the road, and then there is a cyclist over here at point A. Now there is a speed breaker over here. Then there is a man standing over here. Footpath is there, and then there is highway. So now the cycle goes, then it slows down over here, then it goes past the speed breaker, then it goes again fast. Then the man is there, so then he will wait till the man moves, and then he will go again. Now there is highway, so he will go very fast. So if you see here, it got slow, then fast, then slow, then fast, and then it is fast. So it does not move with a constant speed. So now we see that during its entire journey, it traveled in a straight line, but with not constant velocity. So when the velocity of an object changes, it is said to be moving with an acceleration. So now we can see that in this case of the cyclist, the direction of the velocity was considered like it was going straight, this direction, but the magnitude of the velocity was changing, causing it to accelerate. Now when you are when you are applying brake, it is negative acceleration, that is even called as deceleration or retardation. So we can even conclude that acceleration can result from any change in velocity, whether magnitude or direction also. Okay. So now what is the definition of acceleration? It is acceleration is defined as the rate of change of velocity with time. And even acceleration is a vector quantity and its SI unit is meter per second squared. So this is how it's written. It's like meters per second square. There's a square on like the second one. Because if we see, we'll see the formula first, and then I'll tell you how this SI unit came. And even this, when we are calculating acceleration, we don't write like initial velocity so big. So we use V for final velocity, that is at the end of the journey, and then we use EU for initial velocity, that is for the start of the journey. And now we'll see the formula. It is acceleration is equal to change in velocity upon time. So now this is simplified and it is over here. So acceleration is A. Now change in velocity is final velocity minus initial velocity. So final velocity, as I told you, is V and initial is U. So we take V minus U and time is T. Now from this we can even find the velocity, that is V is equal to U plus AT. Now I told you that how this SI unit came. So now if we take this formula, change in velocity. So velocity formula is meters per second, and for time formula it is second. So if you see, there are two S. So if you cancel this, meters per second square. So if we do like this, we get the SI unit. Now let's take a summary of all the things, that is distance, displacement, speed, velocity. The SI unit of distance is meter, displacement is also meter, for speed it is meters per second, and for velocity it is meters per second also. For acceleration it is meters per second squared. Now let's see, is it scalar or vector? Distance is scalar, displacement is vector, speed is scalar, velocity is vector, and acceleration is vector. Now for velocity and for speed it is easy to remember, SS, speed scalar SS, and velocity vector VV. Now let's move to what is uniform motion. Let's see what is uniform motion, and specifically uniform motion in a straight line. So when is a body said to be in uniform motion? A body is said to be in uniform motion if it covers equal distance in equal interval of time in a straight line. For that there is an example given below, that is the table. So now if you see the positions, D1, like this, position 1, position 2, position 3, and so on till position 8. So now if we see the time in second, so it is, here it is 5 second gap, then again 5 second, 5 second, 5 second, and so on till T8. So now if we see that in all the things, the common is 5 second gap. So we can say that it is a uniform motion because there is only 5 second gap. But no, we have to even see the distance. So here if we see, it is 10 meters, 10 meters, 10 meters, 10 meters, 10 meters, so on. So here we see 10 meters is the distance covered. So it is common, 10 meters is again common, and 5 seconds. So we can derive that in 5 seconds it covers around 10 meters. So it is correct, it is 5 seconds, in each 5 seconds 10 meters is being covered. So this is uniform motion because it covers equal distance, that is 10 meters in equal time, in equal interval, that is a 5 seconds. Now let us see what is non-uniform motion. It's like exact opposite. So specifically we'll see non-uniform in a straight line, that is when a body covers unequal distance in equal interval or vice versa. That is if it covers equal distance but in unequal interval, then the body is said to display non-uniform motion. Now there is again example we'll see here. So we can see here also there is eight positions, and here we see there are 5-second gap, 5, 5, 5. So if we see the 5-second gap is common, but we'll see the distance. Here it is 5, here it is 10. How? It should be 5, right? Okay, we'll see the 15. Oh my god. Then it is 20, 25. So this is not an uniform motion, because like it is 5, then it is 10, then it is 15. So how is this common? There should be only one number. So then it is said to be non-uniform motion. So this example is non-uniform motion. Now guys, that's all for this video. We'll meet in the next video, and thanks for watching everyone. And if you have liked the video, please like, share, subscribe and comment to my channel. That's all for this video. We'll meet in the next video. Till then, goodbye.